Mysterious light-colored swirls on the moon's surface have puzzled scientists for years. These lunar swirls, visible even from a backyard telescope, are not just artistic flourishes. Recent laboratory experiments have confirmed that these swirls could be rocks magnetized by underground magma activity. Let's delve into this fascinating discovery. Lunar swirls are sinuous, bright features on the moon's surface, extending for hundreds of miles. Some people liken them to brushstrokes in an abstract painting. However, these swirls are more than just visually striking. They have defied easy explanation for decades. NASA images reveal that the tendrils of some lunar swirls stretch across vast distances, making them a subject of intense scientific curiosity. Recent modeling and spacecraft data have begun to shed light on this twisty mystery, showing that the rocks in these swirls are magnetized. The magnetization of lunar swirls has been a perplexing question. The moon does not have a magnetic field today, and no astronaut or rover has yet visited a lunar swirl to investigate. Michael J. Krawczynski, an associate professor of Earth, Environmental, and Planetary Sciences at Washington University in St. Louis, suggests that impacts could cause these magnetic anomalies. However, he notes that some swirls' shapes and sizes make this explanation unlikely. Krawczynski believes that underground magma cooling slowly in a magnetic field is a more plausible theory for the magnetization of these swirls. To test this theory, Krawczynski and study first author Yuanyuan Liang focused on a mineral called ilmenite, abundant on the moon. Earth rocks are easily magnetized due to the presence of magnetite, a magnetic mineral. However, the moon lacks this hypermagnetic mineral. Ilmenite, under the right conditions, can react and form particles of iron metal, which can be magnetized. Krawczynski and his team found that smaller grains of ilmenite create stronger magnetic fields due to their larger surface area to volume ratio, making it easier for them to undergo the necessary reduction reaction. Krawczynski and Liang conducted experiments to measure the effects of different combinations of atmospheric chemistry and magmatic cooling rates on ilmenite. Their results, published in the Journal of Geophysical Research, Planets, showed that at lunar conditions, they could create the magnetizable material needed. Our analog experiments showed that at lunar conditions, we could create the magnetizable material that we needed. So, it's plausible that these swirls are caused by subsurface magma, said Krawczynski. This finding suggests that unseen lava may be driving the magnetic effects of the mysterious lunar swirls. Determining the origin of lunar swirls is crucial for understanding the processes that have shaped the lunar surface, the history of a magnetic field on the moon, and how planetary surfaces affect their surrounding space environment. This study will help interpret data from future moon missions, especially those exploring magnetic anomalies. NASA plans to send a rover to the lunar swirl area known as Reiner Gamma in 2025 as part of the Lunar Vertex mission. If you're going to make magnetic anomalies by the methods that we describe, then the underground magma needs to have high titanium, Krawczynski said. Evidence of this reaction has been seen in lunar meteorites and Apollo samples, but these are surface lava flows. Cooling underground should significantly enhance these metal-forming reactions. For now, Krawczynski's experimental approach is the best way to test predictions about how unseen lava may be driving the magnetic effects of lunar swirls. If we could just drill down, we could see if this reaction was happening, Krawczynski said. That would be great, but it's not possible yet. Right now, we're stuck with the surface. As we await future missions, these findings bring us one step closer to unraveling the moon's magnetic mysteries.